Welcome back to math. Now we're going to do the practice problems for section 7 on ratios and proportions. Our first problem is to solve for x, and we have a proportions set up like this, so we can do a cross multiplication to solve the problem. So we'll first cross this way. 3 times 60 equals 180, and x times 10 is, of course, 10x. Bring down the equal sign. Now we have 10 times x, so we divide by 10 to get x all by itself. And I'll have x on this side equals 18. Here's problem 2 with another cross multiplication problem. We have our two ratios set up, and so we can cross multiply to solve. Going this way, we have x times 15, 15x, equals 5 times 30. 5 times 30 is 150. Now, x is being multiplied by 15, so we will divide by 15. We have to do the same to both sides. X equals 10. In problem 3, it says if Joe earns $10 per hour, how much does he earn in 8 hours? Now we need to set this up ourselves. It's going to be a direct proportion. The more hours he works, the more he earns. So the relationship is between dollars and hours. And we know that he gets $10 per 1 hour. So applying that to the question, what we want to know is how much does he earn in 8 hours? So again, I'm going to keep all the hour information on the bottom, and what we don't know is up here, it's about how many dollars does he earn. So here's our cross multiplication problem. X times 1 is just x, and 10 times 8 is 80. So Joe will earn $80 in 8 hours. Problem 4 is another setup of a direct proportion. This time we've given the information in this format. It says the ratio of students to teachers is 16 to 1. That's how we read that. 16 to 1. How many students are taught by 3 teachers? Well, all right. It's pretty obvious here, I think, that the students and the teachers are have the relationship. So I'm going to write students on top, teachers on the bottom. Doesn't matter which one is on the top or the bottom. So the ratio is listed as 16 to 1. So it's going to be listed in the same order, students, teachers. So this is students, 16, and teachers, 1. Right? So now we'll apply this to what we want to know. How many students, all right, we'll keep that on the top. That's how many. We'll represent that with x, are taught by 3 teachers. Great, so teachers still along the bottom. Here's our cross multiplication problem. X times 1 is x, and 3 times 16 is 48. So the 3 teachers will teach 48 students. Problem number 5 says Mary wants to make lemonade that is 10% real lemon juice, and the rest is water. How many ounces of lemon juice does she need per 60-ounce pitcher? So our relationship here is between the amount of lemon and really the total amount that she's going to make. And we're told that her lemon is 10%. That's 10 per 100. 100 being the total, and 10 parts of that is going to be lemon juice. Okay? And now we'll apply that to the rest of the problem. So she's going to make 60 ounces, and how much lemon juice does she need to be 10%? So now we can cross multiply. 100x goes to this direction, and in this direction 10 times 60 is 600. So divide by 100, since that is what x is being multiplied by. We get x equals 6. So Mary needs 6 ounces of real lemon juice in her 60-ounce pitcher to be 10%. And problem 6 says it takes Bill 3 hours to run 12 miles. How many miles does he run per hour? So we're talking about miles, and we're talking about hours. So let's decide 1 is going to be in the numerator, One's going to be in the denominator. Doesn't make any difference. So it takes Bill 3 hours to do 12 miles. Okay? How many miles, miles being on the bottom, that's how many is X, does he run per hour? So that's just 1 hour. Let's cross multiply. 1 times 12 this way is 12, and this way 3x. We need to divide both sides by 3. 12 divided by 3 is 4, and that is x. So he runs 4 miles per hour. Here's problem 7. It says it takes 6 people a total of 4 hours to mow the school's grass. How long would it take 8 people to mow the same grass? Okay, this is an indirect problem where the number of people and hours multiplied together are going to give us the amount of time that it takes to do this job. And in this case, it's how much to mow the grass. And they tell us that 6 people take 4 hours. That's 24 hours total to mow the grass. So if we change the number of people to 8, how many hours would that take to mow this, to do the same job, which is still a 24-hour total job? Well, now we divide each side by 8, and we get x by itself on that side, and 3 over here. So 3 hours for 8 people to mow the lawn. Here's a bonus practice problem for this section. It's about an indirect proportion, but it's an unusual kind. And just watch in case you come across this kind of a problem in the future. Here's a problem that says it takes Anita 6 hours alone to do a job, but it takes Bob 8 hours alone to do the same job. How long will it take them to do the job if they work together? All right, we have to set this up a little bit differently, but we have Anita hours equals the job. So Anita can do the job in 6 hours to do one job. That means that Anita, I'm going to divide both sides by 6. Anita can do 1/6 of the job in an hour. For Bob's hours, Bob takes 8 hours to do the same one job. So Bob can do 1/8 of the job in 1 hour. All right, so let's put them working together. So that is Anita, 1/6 per hour, and Bob together. And we want to know how many hours, we'll call that x, to do our one job. So we have some fractions that are being added. We need to come up with a common denominator. I'm going to use 24. 1/6 is 4 24ths. 1/8 is 3 24ths. All right, now we have 7 24ths x equals 1. I need to divide both sides by 7 24ths. If I divide by 7 24ths, that's the same as multiplying times 24 over 7. So the answer is 24/7 an hour. If I actually went to a calculator to do that, and what we get is that that is 3.4 hours. And that makes sense because it should be less than Anita's 6 hours, but it's not completely half of the hours for Anita. It's a little bit more than half of her hours because Bob works a little bit slower.